I'm going to do something a little different here on special factoring techniques because there's actually 3 of them. I'm going to break them down one at a time and give you one clip at a time. So yes, we're still doing factoring, we're still doing quadratics, but the special techniques are basically a shortcut. All right, so I'm going to look at a shortcut here. We notice something that goes x squared minus y squared. All right, this is called a difference of squares. Difference of squares. All right, if you notice, difference means subtraction, so we have our subtraction, and squares means on the front side and the back side of my subtraction are squares. So that's how we're going to talk, and that's what we're going to look like today. So the first one I want to look at is 4x minus 9. And this guy is a square. So 4x squared minus 9. Notice it's a difference. It's 2 terms. We've got to all of a sudden think red flag. Let me get my red marker out because red flag, that's a difference of squares. And the way a difference of squares works, if you remember, is our FOIL problem is it has to be opposite signs. Our opposite signs gets rid of that outside inside term. All right. So really all we have to do is the square root of that guy, which is 2x, which means it's also over here, and the square root of 9, which is 3. So 4x squared minus 9, and we have a plus 6x and a minus 6x, which goes to 0 x's. So there is my answer. Notice how much faster we get there. Now, if you remember me talking in class or in previous sections, the shortcut from this guy to there is 3 to 5 seconds. It's not a huge deal, but from there to there can actually be 30 to 35 seconds, which can be game changing when we're taking a quiz or a test. So it is kind of nice to know these special products. Let's look at another one, and this one's a little bit longer than that last one. K to the 4th minus 81. Here again, obvious signs, 2 terms. It's a subtraction. So are they squares? Well, squares meaning they have a square root. So k squared times k squared gives me k to the 4th. So yes, because I already know that 9 times 9 is 81. So the 9's on the back side. I got k squared on the front. And to get rid of my middle term is a positive and negative. So there's my answer. The problem with this answer is it's not completely factored. It has to go all the way to prime. Now, the k squared plus 9 is prime. We can't do that, and I'll explain that here in just a second. The k squared minus 9 is another difference of squares. So we can actually go, another set of binomials, plus and minus. Square root of k squared is just k. And the square root of 9 is 3. Now, I still have to bring this k squared plus 9 down because it is a factor. It just doesn't factor any more than a k squared plus 9. So in this case, there's my answer. Now, let's go to a different slide, and let's explain this k squared plus 9 thing. And it's different than the k squared minus 9 thing, because the k squared minus 9 is a difference of squares. If I go back in lessons past and say, oh, this is a quadratic, I can say this. I can say k squared plus 0k plus 9. And now all of a sudden I've got this trinomial, which is equivalent to that binomial. If I go first times last, I get 9. 2 factors that add to get middle, which is 0. I can't plug in a number, any 2 numbers here that will get me 0 that will multiply to get 9. Yes, 3 and 3 works, but when I do 3 and 3, 3 plus 3 is 6, not 0. If I do negatives, it's still negative 6, not 0. If I do one sign and then the other, so a positive here and a negative there, I get 0, but then I don't get positive 9, I get negative 9. Whereas the difference of squares actually does work. So plus 0k minus 9. Now I get a negative 9, 2 factors that add to get 0. and I get that 3 and 3, one of them's negative, and all of a sudden it works. So be very careful. It works for difference of squares, but it does not, absolutely does not work for sum of squares.